Hello, students. We are going to look at linear equations with fractional coefficient today. Now, this is actually not an assignment that I just asked you to do. This is actually a revision, right? Because algebra is important. It's the foundation of many of the advanced mathematics that you're going to learn. So it's good to make sure that we are successful with algebra, right? So here is actually just a series of linear equations. They are not complicated, and you are required to solve them, which means finding the value of x. What I want you to take note is to focus on proper presentation, right? Proper presentation. Now, what is actually required when we are trying to present the solution to a algebraic equation? And the important thing is equivalence. Oops, how do you spell that? Okay, pardon me, my spelling is not the best. Equivalence equation, right? The idea is we need to write equivalence equations from one step to the next. Calculations is not what we want. It's no point having calculations. For example, this is bad presentation. If I were to solve this and I say, okay, in that case, I have 6 times 3 equals 18, x equals to 18. This is bad, okay, no good, right? So instead, what we want is to write down equivalence equation from one line to the next, right? So in this particular instance, all I need to do is, right, to multiply by 6 on both sides, I get x equals to 18. And that's all I need. But of course, as the equations get a bit more complicated, it will be more than a single step and a single line. Okay, so for the next example over here, I could do 2x equals to 20, right? By multiplying by 5, so x equals to 10. This is good, right? Now, what is bad, right? Bad example will be, you will just go, okay, maybe I have 5 times 4 equals 20, 20 divided by 2 equals 10, x equals to 10. Bad example. Don't do that, right? Okay, so clear. Let me just clean up this. Okay, bad example. Don't do that. We don't want the bad example. Okay. So with this understanding, that's how we're going to focus on our presentation. So hopefully you get them all correct. So yeah, clean it properly, right? So change to blue, and let's go. So what do we do here for the next one? Okay, so here we can have just a quarter x equals to 9 minus 5 is 4. So x is equals to 16. That's all I need to see. Here, 3 over 8, x equals to 2 plus 1, which is 3, right? So 3x is equals to 24, x is equals to 8. Okay, right, moving on very quickly. We have, negative 2/3 x equals to negative 6, right? So down here we have negative 2x equals to multiply by 3, negative 18, x equals to 9, right? Because negative 18 divided by negative 2 is positive 9. Remember, negative number divided by negative number give us a positive. Okay, so on this side, okay, we can do the same thing again. Negative 3x over 4. This will be negative 5 minus 10, negative 15, right? If I multiply this by 4, I will get negative 60. So negative 60 divided by negative 3 give us positive 20. Okay, that's one way you can do this, right? Okay, now over here, all we need to do is subtract 4/5 x on both sides. So I'll just end up with this situation, right? So my x is equals to negative 30. Okay, over here, 2 sevens. So it's safer to use calculator here to help. 2 sevens minus 3, right? We will have negative 19 over 7x equals to 19. So over here, negative 19x is equals to 19 times 7, which is 133. So x is equals to negative, right? So 133 divided by 9, 19, right? We'll get back 7. So negative 7. Okay, so take note, positive number divided by negative number give us a negative, right? Okay, over here, what we can do is we can have a negative 56x plus 2 over 9x equals to negative 8 minus 3, right? So using the calculator, 9 minus 5 over 6, this will give us negative 11 over 18x equals to negative 11. Okay, so from here, okay, actually if you are quite aware what's going on, we can just use negative 11 divide by negative 11 over 18, which will give us a 18 over here. Okay, right? Okay, now how about this one, right? So for this one, what we can do is we can actually combine them and make them the same denominator. Okay, so what I can do is make them common denominator. I can have a 3x over 5 plus, now 4, if I multiply by 5, this is 20 over 5, right, equals to half. Now, I would actually prefer to write it in this way, right, in this form. Come on, Apple Pencil. There we go. Okay, you can write it in this form, right? So what this does is now, if I were to multiply by the LCM of the denominator throughout, it actually clears the fraction, right? So if I multiply by 10 throughout, I will actually end up with 6x plus 40 equals to 5x minus 1. Okay, so this gives us 6x plus 40 equals to 5x minus 5. So x will be equals to negative 45. Okay, right, let me write it cleaner, better handwriting here. Right, okay, so moving on. Now here, same situation, I will first prefer to write it in this way, x plus 1 over 2 equals to 2x minus 1 over 3. Now, because this is a situation where we have one fraction equals to another, it's perfectly fine to just do a cross multiplication. So we have 3x plus 1 equals to 2x minus 1. Expanding it, 3x plus 3 equals to 4x minus 2, right? So put them together, 3 minus 4 is negative x equals to negative 5, x equals to 5, right? Now on this side, what's the situation? Well, there's a few things we can do. Number one, we can actually rewrite it in this way, right? So, and what happened is the 4/9 of the 2x minus 3, if I could just move it to the other side of the equation. So it will be subtraction to addition, right? Because I'm adding it on both sides. You have this situation, a 9. Now, same thing, it is one fraction equals to another fraction. We can do cross multiplication. So 9, 5x plus 7 equals to 4 times 8 is 32, 2x minus 3. I could safely do that, right? So this will give me 45x plus 63 equals to 64x minus 96. Okay, putting them together, so 45 minus 64, negative 19x equals to, well, we have 96 and 63, negative 159. So x will be equals to (8 and 7 over 19). Okay, looks like there's no way to simplify it. Let's double check to see if we made everything correct. Okay, looks correct. Well, sometimes if I do make an error, just put it in the comment and I will update it in the future video, right? Thanks for your help. Okay, let's move on to the second page, right? So here, okay, what happened is we need to know that this is actually 8x over 8 plus x over 8 equals to 27, which means we have 9x over 8 equals to 27. X is equals to, so we have 27, you can actually divide by 9 times 8, which gives us 24. right? Quite easily done. Okay, so same thing here. Okay, we have 5 minus 1/3, which gives us a 14x over 3 equals to 42. So x will be equals to, so 42 times 3, 14 equals to 9. Okay, use your calculator to help you. Let's just make sure the presentation is right. Okay, so here we have a half and we have a seventh. So that will give us 9x over 14 equals to 5, right? So 9x equals to 14, 70, x is equals to 7 and 7 over 9. Okay? Right, here, well, same situation, right? We have a quarter, but if you really want to, we can actually make the them common denominator. It's not that difficult. So in this case, I can go 9x minus 4x over 36 equals to 10. 5x equals to 360. X is equals to 72. Right? So there's actually more than one way to actually go about solving the question. The important thing is equivalence equation, right? Every line, equivalence equation. So here, multiply both sides by 9. That is 7, right? So for x equals to 28, x equals to 7. Okay. Same scenario here. This time round, feel free to actually add 4 on both sides to get this situation. So 7x plus 2 equals to 24. 7x equals to 22. X equals to 22. That will give us 3 and 1, 7. Right? We're almost done. So here, okay, what we can do here is we can again make them the common denominator. Now, in this instance, I like to just put the 2 in this manner. Right? So we got x minus 1 over 6 equals to 0. Now we multiply by 6 throughout. We have 5x plus 2x minus 2 equals to 0. 7x is equals to 2. X equals to 2 over 7. Right? Now, for this scenario, right, we can move, because it's a 0 on the right hand side, so we can move one of the term over. Okay, so it will look like this. 2x plus 1 over 5, and since it's one fraction equals to another, we can actually safely do a cross multiplication. So 5, 3x plus 7 equals to 8, 2x plus 1. Okay, this will give us 15x plus 35. This is 16x plus 8, right? So that will give us x is equals to 27. Okay, almost done. A couple more example. So here, what we can do, well, again, 1 is actually the same as 4 over 4, right? So we can actually put them together. X over 4 here equals to 5x plus 8 over 8. Now if I multiply everything with 8, we have 8 minus 2x equals to 5x plus 8. Putting them together, 7x is equals to 0. Oh, x equals to 0. Nice number. Let me check if it's correct. 0, 0. Yeah, it's right, right? Okay. So on this side, what do we have? Well, we can make everything, all the denominator common again. So we can make the denominator 20. So in this case, it will be 5. 9 minus 2x, okay, plus, on this case, I need to multiply 2, so 6, x plus 3, right, over 20. This will be equals to 20x over 20, right? So now we expand it carefully. 45 minus 10x plus 6x plus 18 equals 20x, right? So put them together. 10 plus 6 plus 20. We have negative 24x is equals to 5 minus 18. 7, so negative 27. X will be equals to, okay, you have a 1 and 1 over 8. Okay, final two example. Well, again, what happened is this is actually equals to 9 over 4. So the common denominator, in this case, between 4, 9, and 2 will be, let me see, 36, right? So 36, I multiply by 36 throughout, so 36 is, so 36 times 7 over 2 is 18, right? Okay, times 7, 126. So quite a large number, right? It's okay. 1 minus, on this one, you'll be times 4, so 16. 8x plus 1, and then on this side, it will be equals to 81. So this is what happened when I multiply by the LCM of the denominator, which is 36, just multiplied throughout. So that's what we get. Then, of course, after that, we expand carefully. 126x minus 126 minus 16 times 8 give us 128. So 128x minus 16 equals to 81. So negative 2x equals to 81 plus 126 plus 16, 2, 2, 3. So x equals to negative, okay, 1, 1, 1.5. Nice number, right? Okay, and finally, this one, okay, we have 7 and 6 for the denominator. So let's make the denominator 42, right? 42. So 2 times 42 is 84 x over 42 plus this one will be 6, 2 minus 5x. Now I could, since I'm very confident that my denominator is going to be the same, I can actually just write the numerator, and on this one it will be 7, 20x minus 9, and 11 plus 2, 462, right? So expand carefully. 84x plus 12 minus 30x equals to 140x minus 63 plus 462. So 4 minus 30, negative 86x equals to, let's try 462 minus 63, minus 12, 387. So x is equals to, there, negative 4.5. All right, so this is what I've gotten. Well, if I made a careless mistake somewhere, let me know in the comments so that I can update it in the next version. All right, so I hope you have been successful. Have a nice day.